Hello everyone. Today I Vibhu is going to explain you module 2, the application layer, in a short and precise manner, the way in which even a beginner can learn about the contents of this module. So first we will start by the basic definition of a application layer. As we all know that application layer is the top layer of the network communication model. It it is both in the OSI reference model, which is 7-layer model, and in the TCP/IP model. It's used to exchange information between different devices on network. It's called the application layer because it's the layer where applications or programs that run on our computer or mobile device communicate with each other. In other words, the application layer is responsible for facilitating communication between the different software applications that are running on different devices on the network. Like for an example, when you send an email from your computer, the email applications on your computer communicates with the email server through the application layer of the network model. Overall, we can say that the application layer plays a crucial role in enabling different applications to communicate with each other across a network, which makes possible for us to use the internet and other network technologies in our daily lives. The network application is a type of software application that runs on a computer network such as the internet or a LAN. These applications use network protocols such as TCP/IP, HTTP or FTP or to communicate with each other, the other devices on the network, and to transfer the data. The network applications uses two main architectures. These are the client-server architecture and the P2P or the peer-to-peer architecture. In the client-server architecture, it involves the centralized processing and storage of data, whereas in the peer-to-peer architecture, it involves the decentralized processing and storage of data. There are other differences also between these two. In the client-server architecture, there is a clear separation between clients and servers. That means the client and servers can be differentiated, whereas it is not possible in the case of peer-to-peer architecture. In the client-server architecture, data is provided only in response to a request, whereas in peer-to-peer architecture, peers have authority to request as well as provide a service. In the client-server architecture, purpose is to store and exchange information, whereas it is not like that in the case of peer-to-peer architecture. The goal is to maintain connections among peers in the P2P. Moving on to the processes. Process is defined as a program that is running within an end system. There are two main types of processes. Communicating process, it refers to a process that the exchange of information or messages between different programs or components of program. This communication can happen in various ways, such as through shared memory, pipe, sockets, or message queues. The second type of process is the addressing processes. Addressing process is the process of identifying the location or identity of a specific program or component within a larger system. This can be done by various ways using various addressing schemes such as IP addresses, MAC addresses, or memory addresses. The purpose of an addressing process is to enable programs to find and communicate with each other. Socket. What is socket? It is an interface between the process and the computer network. Process sends or receives messages to and from its socket. There are two sockets involved in any communication, and they are present on the sender side and the receiver side. When we talk about the transport layer protocols, there are basically two different types of transport layer protocols available to use. These are TCP, which is transmission control protocol. It is a connection oriented protocol that establishes a reliable, ordered, and error-checked connection between two endpoints. It guarantees that all data packets are delivered in the correct order and without errors. TCP is often used for applications that require data accuracy and reliability, such as file transfer, email, and web browsing. The UDP is the second type of transport layer protocol. It is a kind of a new version of TCP and has some advantages over it. It is a connectionless protocol that sends packets of data called datagrams from one endpoint to another. It does not guarantee delivery, ordering, or error checking of data. UDP is often used for applications that require speed and efficiency, such as video streaming, online gaming, and voice over internet protocol applications. Moving on to the next part of the module 2 is HTTP. HTTP is at the heart of the web and is defined in RFC 1945 and 2616. It is implemented in two programs, a client program and a server program. Under HTTP come the web objects. Web objects can be anything like HTML file, JPG image that appears on a web page. Each one of them can even be stored on a different web server. Web browsers implement the client side of HTTP. There are different types of HTTP connections. These are persistent HTTP connections, non-persistent HTTP connections. In the persistent HTTP connection, multiple objects can be sent over single TCP connection between client and the servers. The speed of file transmission for the persistent will be 1 round trip time plus file transmission time. And for the non-persistent HTTP, it will be 2 round trip time plus file transmission time. In the case of non-persistent HTTP, single object can be sent over a single TCP connection between client and the server. Then comes the HTTP messages. HTTP protocol uses messages to communicate. There are two types of messages, the request message and the response message. We will be discussing more about HTTP. There are various request messages such as post method, in which the user input sent from client to server in entity body of HTTP post request message. In the get method, it includes user data in URL field of HTTP get request message. The head method, the request headers that will be returned if specified URL were requested by HTTP get method. Put method completely replaces the file that exists at specified URL with content in entity body of post HTTP request message. The delete method, it deletes objects in web server. Some HTTP response status codes are 200 OK. That means that the request is passed successfully and the requested object appears later in the message. 301 moved permanently. That means that requested object moved new location is specified later in the message. 400 bad request. Request message is not understood by the server. Then comes the last 404 not found. Requested document not found on the server. The last is the DNS. DNS is basically domain name system. It helps in converting hostname into IP addresses and IP addresses back into hostname. Without DNS, it will not be possible for us to remember easy names like Google or Facebook or Instagram. We have to remember the IP addresses of each of these sites if there was no DNS. It is a basically hierarchical decentralized naming system used to translate human readable domain names that I told earlier. So why do we not have a centralized DNS? The main point is that it will lead to a single point of failure, that like a system failure occurs in the centralized DNS, all the system will fail. The second is traffic volume, the third is the distant centralized database, third is the maintenance, and fifth, it doesn't scale much. The DNS root name servers, it is an incredibly important internet function and internet couldn't function without it. DNNSEC, it provides security and ICANN manages root DNS domain. So how does DNS work? A computer browser requests to visit example.com. The company DNS is checked but the requested address is not found. Then the ISP DNS is checked next and is also unable to find the address. The root DNS is checked and the IP address is found. IP address XXX is returned to the computer. Computer receives IP address and prompts the browser to open the given address. Thank you. I hope this tutorial will help you understanding the basic concepts of module 2.